Today my guest is Mike Amundsen. Mike, how you doing?
Good to see you. Good to see you, Dave.
Mike, what do you do?
I'm a consultant. I work in basically building web applications, usually at internet scale.
All right, and you live in the great Commonwealth of Kentucky.
Kentucky, that's exactly
That's
right.
your favorite Commonwealth.
It is my favorite Commonwealth too. There aren't too many of them.
Yep. I just caught your talk on programming the web with HTTP and REST.
And REST, that's right.
So there's a lot of broad words there. Programming, HTTP, REST. Well, I should be more specific, but REST. Define that. What is REST? I hear that word a lot, and I'm not sure that I have a great grasp of what that means.
Well, REST refers to an acronym that was coined in the year 2000 in one chapter of a dissertation by Roy T. Fielding, Representational State Transfer. It was his culminating work in school, and he had been working on documenting and establishing the HTTP specification. So his dissertation actually reflects things that he had learned while working in the early days of the web. So REST is really a style or an architectural pattern that is used over HTTP or used in the internet. And when people talk about REST, a lot of times they're talking about, I have a REST service, or I have a REST API, or I want to program in REST. But really REST is a pattern, a style like Gothic or Swedish Modern or something like that.
Well, that's interesting. You said, 2000 this paper was written?
Yeah.
10 years ago.
Yeah.
And I've been hearing this word a lot in the last 12 to 18 months. Not before that. I don't think I ever heard of it in 2000 through 2008, for example.
That could be. Since it was a dissertation, it really doesn't get a wide kind of audience. But it's influenced the building of the web from the very beginning. You might really think of it as, we don't talk about it because it's always there. And it's only recently, as we've kind of gotten beyond into the web AJAX world, that people are thinking, well, maybe there are other ways to do applications on the internet or applications over HTTP. And some of those techniques are now coming to surface, and they're being labeled kind of REST-oriented, or they're RESTful or something like that.
Okay, so you sort of partially asked a question I was about to ask, which is why all of a sudden are we talking REST when we weren't before? And it's because the web has changed. The way that we view the web has changed. The way the applications are being built has changed.
I think more and more applications are turning into services rather than contained applications. Okay. You hear a lot about linked data and a lot about exposing your data. And when you do that, this REST pattern, or this style of architecting an application, works very, very well over HTTP. So I think that's why you're seeing more of it.
Okay, and so what are the things that go into this pattern?
There are a set of constraints. Since it's a pattern, it's not really a spec. It's not like HTTP where you have rules about what you do. But there's a series of constraints about how you would organize an application. And the biggest ones relate to the notion of there's what's called a uniform interface. And rather than the way we build applications local, where we create a class and create functions and we expose those functions, that becomes the interface. Yep. Over the internet, since you've got so many different clients, so many different servers, and it's really kind of anarchy, you need it really is, right? Anybody can join. You really need a simple interface. So the notion behind the HTTP model and exposed in this pattern is their interface is uniform, consistent across everywhere, and that's what we know as get, post, put, delete. That sort of set of operations that you can execute over the HTTP protocol. So that's the uniform interface. That's the first one that people think of.
Okay.
There are a couple others, and that is the notion that when you're sending messages back and forth, the message is set in two different parts. There are some control data and there's message data, and that's called self-descriptive, like everything is all in one package. That way if a server goes down, some other server can take a message and do everything with it. And the idea also is that messages should also be identified by an ID. So there's this universal ID, which we use as the URL.
Okay. So a web browser or a web page's address would be
is a good example.
Okay.
And then lastly, the big thing about the REST pattern is that the application or the state changes or going from one place to another is handled by links called hypermedia. So when you send a message back and forth, it needs to be self-contained, it has a single, a known address, and it contains links to the next thing you can do.
So we say links, I think of hyperlinks,
right?
Anchor
Hyperlinks
tags in an HTML page,
right? It was sometimes called hypermedia. There's a kind of a quirky phrase, hypermedia as the engine of application state, that appears in the dissertation that people refer to a lot. But really, it just means links in the message you get back.
Okay, so this is a way to move from one state to another. Could be moving from one document or one web page or one service call to another.
Absolutely, and if you think about the way we move in an application, there are different kinds of links, ways that we move things around. There are links that embed, like an image link says to the browser, follow this link and go get it and display it here. Mm-hmm. That's an embed link. You've got operational links that are sort of programming in nature, like script links. Go get this script and run it. Mm-hmm. Go get this style sheet and alter the page. Mm-hmm. And then you've got links that navigate, like anchor tags that say, follow this link to get to a new place. And then finally, you have links that contain included data, which are forms. So when you follow this link, fill out these values and send that to the server to do something with.
Okay. How would you distinguish REST from, say, SOAP web services?
Yeah.
Are they different, or is one a subset of the other, or are they completely different?
Well, REST being a style is different than SOAP being a format.
Okay, so this isn't really a fair comparison I've asked you to do. But,
yeah.
I've heard that comparison.
No. It's actually very common. It's like, do you want to do SOAP or do you want to do REST? I get this question all the time.
Uh-huh.
And the difference is SOAP uses a special XML predefined format to send messages around. It turns out that you can send SOAP messages directly over IP ports. You don't need the web to do that.
Right.
But most people use the web, which is using HTTP. Oh. So most people actually put a SOAP message inside an HTTP message and ship it around. HTTP itself says you can put any kind of message in there. So you might think of it as SOAP over HTTP is one kind of HTTP.
Okay. Okay, and then so as a developer, what are the kind of issues that I need to be aware of when I'm building RESTful applications?
Right. So
is that a right phrase? I don't want to.
Yeah.
I don't want to get hung up on the semantics here.
Yes.
But words are important when we're talking about this.
No, actually, it's a really good point, and I do use the phrase RESTful or REST-like or applications that follow the REST model or REST style or something like that. And there are a series of things that I think about. When you think about building RESTful applications, you really want to use the power of HTTP, because as pointed out in a lot of writings, the appeal of REST is that it actually surfaces or exposes the actual patterns that are already in HTTP, because Fielding was actually influenced by HTTP when he talked about it.
Okay.
So you think about the power of HTTP, and we touched on some of those in his example. There are self-described messages, there are a limited set of methods. Another big thing that HTTP uses is this notion of a media type. So there's text WAC HTML or application XML or application JSON. These are media types.
Okay, and these are just, this essentially tells the client how to handle the data that I'm sending down.
Right.
So if I say it's going to be sent as HTML, my web browser knows to parse it out and display the HTML rendered properly. If I say it's going to be XML, it'll render it a different way.
Right, or a PDF, or an image. These are all types, right? And they were borrowed from the mail system. So MIME is really the MIME type, right? So that's a big part of HTTP, sending messages as certain kinds of media types. And just as the method list, get, put, post, delete, there are a couple others had options, that's really limited. The set of media types that everybody understands is a relatively limited set too. So what happens is when you say I'm exposing a certain media type or I'm sending something as a media type, you're sort of telling everyone this, what to expect. So the media type sometimes is referred to as the contract. So that's the contract between client and server. So if a client says, please send me an XML document, they're sort of saying, I understand what to do with that document. So media types are very important. The thing is, media types are kind of a mishmash because they came from the internet mail system. They don't have all of the same power or all of the same expressiveness throughout the whole list. Think of I think of types in three ways. There are simple types like text whack plain, like you would get in a text document. Mm-hmm. So it's just a simple piece of data. There's no magic inside that, right? And then there are well-formed types such as application XML or application JSON. You can tell if that data format is correct, if it's missing a tag or a brace or something like that.
Okay.
But you can't really tell too much more about what's inside of it. And then you have types like application Atom. So Atom is a very specific type of XML, and it has certain requirements that items have to appear, and they appear in certain ways, and they have to contain certain values. So when somebody says, I'm giving you an Atom document, you can assume not only that it's an XML, but you know where to find the link for editing. You know whether or not it's a list. You know whether or not it has extensions. So it actually has some of this hypermedia information. You've guaranteed a lot more in the contract.
Okay.
So
there's a specific schema around that XML.
Right. So that's part of that self-descriptive message. I'm sending you an Atom document. Clients know exactly what to do with that.
Okay. Is that list of MIME types, is that extensible, or are we stuck with what we have?
Well, there's a couple of different things. You can actually invent a type anytime you want. You have to hope that everybody that you're sending it to understands it, right? Now, when they defined the XML type, they created a rule that said anything that ended in plus XML could be part of the club. So you can kind of invent one that has plus XML, and most XML clients will know how to handle it.
Okay, maybe add your own validation schema to that XML.
Right, so that's exactly right. So a lot of times you'll use a schema in XSD or something for that. Exactly. So we do need some new data types. I think one of the things that I see is there are an awful lot of data formats, but not a lot of MIME types. And that means there's not a lot of link or other semantic information inside it. And as we move into this web where we're talking about semantic links and links of data and the web of data and all that, one of the things that I don't see enough talking about is the semantic information about what to do with the data. We're doing a good job now of creating formats that say what this means. That's what RDF and that group is about, the semantic web. But we're not yet talking about what I can do with what I have, and that's going to be, I think, the next big push.
Okay. Well, let's talk in more practical terms, just from the developer's point of view, just the kind of the things that we need to.
Yeah.
I want to build my RESTful application. I know that I need to be aware of the different HTTP verbs, because that, if I understood you correctly, that's the contract that the client sends to the server, right? Client sends a request. It's either a get or a post or a put or whatever. Right. The server sends information back to the client, and its contract is really defined by these MIME types. Have I got that right?
That's pretty close, but those contracts are on both parties.
Okay.
So you think about it, a server could say, you can post some information to me if you use the Atom media type.
Oh, okay. So
right?
they can go both ways.
So it goes both ways. And when a server says, I support these certain methods, clients can assume that certain things about those gets and puts and posts. Okay. We talked about it earlier, the notion that there are safe methods and idempotent methods. So the notion that it's safe for me to keep sending gets because nothing's really going to change on the server. I can keep hitting the refresh button over and over again. It's not a problem.
Yeah, I'm just reading data, not writing data.
Idempotent is when you write data, but it's always going to be the same data every time. Put is like that. So if I put a form to a server, or I put an XML document, it just replaces the one that's there with the one I put. That's really important. If the net goes down and I don't get a response, I might put it a second or third time. Think about SQL update command. Right. Update set field equal to 3. It's always going to set it to 3. It's not going to make it 9.
Right, as opposed to the insert command, for example, which you run that twice, you'd actually get 2 records.
Exactly right. So idempotent is I can repeat it and it will always end up the same way. Safe is that it won't make any important changes to the system. And whenever a server or a client knows about that list of uniform methods, it's not just that the method names are the same, it's that both parties treat them exactly the same.
Okay.
By the way, the one method I didn't mention is post.
All right, and post is not safe, and it's not
idempotent.
Idempotent.
you have no idea. There's no guarantees.
Okay,
There's
just
no
do
guarantees.
something. It might be launching some blow up the world workflow for all you know.
Absolutely. Or I might just keep adding row after row after row after row.
Okay, what else does a developer need to be aware of?
So we've talked about the idea of the media type as a contract, or a media type understanding. We've talked about methods. We talked briefly about the notion of control data. One of the great designs of HTTP is that information that could be shared, like should this be cached, does this need to be authenticated, when's the last time this was updated on the server, that's set in control data, what's called HTTP headers. It's not in the body of the message itself. So caching servers, authentication services, content distribution networks, they can concentrate on the control data and not have to try to figure out how to understand the contract inside the message. So this is very, very efficient. It's very, very effective. So good use of control data and not mixing control data and message data is really important. A great example would be, I see cases where people write inside the body caching information about how long this message is good for. Well, that's good if the client understands that, but all those caching servers out on the internet will never know that. If you put that same information in control data, everybody gets to cache that information.
And that's because the control data, the semantics of the header are more tightly defined.
The semantics of the header are defined by the HTTP spec, so
okay.
If you're a server, you have to follow those rules. If you're a caching server, you have to follow those rules.
Okay.
Yeah.
You say control data, I would use the word metadata. Is that
you could say metadata,
okay.
or
data that describes the message.
Exactly right. Okay. And in the parlance of the HTTP application protocol, they just say headers.
Okay.
HTTP headers.
Okay.
So we talked about headers, we talked about the contract of the body and the uniform interface. Another really important aspect of the REST pattern over HTTP is separating the representation from the data itself. And that is that I may ask for a resource like a customer, give me the customer. Well, I don't get the customer back. I get something that represents the customer, and that's the format of that body of the message. So when I implement applications, I have a separation of concern between getting the data maybe out of the database and how I'm going to represent it to the client. So the client may send a media message that says, I'd like to see this as a JSON object. So I'll get the data and then fire off the transformation that turns that into JSON to represent that information and send it back to the client. So separating the representation of the data from the actual data itself, I can store the data as XML, I can store it as a database row, I still will send it back to the client as JSON if that's what they want. So that's a big deal.
Yeah, that's a really big deal. And this isn't really unique to REST, but
no.
Maybe it becomes more important in RESTful applications.
It's a pretty important part of that style. The views in MVC really match very closely, right? You could change the view, and that doesn't affect that's not tied to the model, right?
Correct. Right.
So it's really the same kind of notion. So that's nothing really unique, but it is an important application.
Oh, so is ASP.NET MVC application or Ruby on Rails application, is that an example of a RESTful application?
They have a lot of RESTful aspects to it. So it's sort of like saying, is that an example of a Gothic building? It's like, well, yeah, I can see some columns and I see some other things. So it's really not sort of a yes or no kind of deal, right? And I think that's really important. There's really two ways to go. When people
interrupt there, because I had this discussion about service-oriented architecture a long time ago. Is that the same thing? There isn't. Somebody says, "Is this a service-oriented architecture?" Well, these are the attributes of service-oriented architecture, and you may have some of them, you may not have all of them. So it's kind of SOA-ish.
Yeah.
And there isn't really a cutoff to say that it must have these 7 attributes.
Right.
At least that was the point of the fellow I was talking to. And I sort of took that to heart, is that service-oriented architectures if that's your goal, then you want to implement as many of these attributes as possible.
Right.
But if you don't implement it all, it's not the end of the world. It's just not as SOA-ish. And the same thing is true of REST here.
Absolutely, absolutely correct. And REST doesn't apply to everything. Okay. Because of the way HTTP works and the internet works, there are a lot of built-in inefficiencies that have to do with being able to support caching servers and layers and all that. You would never use the REST pattern to, say, transfer peer-to-peer applications, right? BitTorrent or chat or these other things. That's not a good RESTful interface. So it's really just a pattern or a style.
Okay. Tell me, where can people find out more about Mike Amundsen?
So you